For this one, there's lots of ways you could go about solving. What would you guys like to do? Like, how do you want to handle these fractions? Do you want to try to make them go away? Do you want to just make them decimals? What do you want to do? Okay, so in that case, if I want this x over 7 to no longer be a fraction, what should I multiply it by? By the denominator, which is, so if I do have to do that here, then I have to do it to every part. So in that case, when you do that, I get x because 7 times 7 and then divided by 7 cancels out, minus 7/5. And maybe let's try, because I know 1/5 is a decimal that ends. So 1 divided by 5 is 0.2. And then let's try timesing it by 7. So let's make that 1.4, see if that helps. And then same with this, like this is a 1/2, even though the 1 is not written, it's implied. So it's like 1/2 x. I'm going to make that 0.5, but then we still have to times it by 7. So now it's 3.5x. And then 7 times 3 is 21. All right, so that eliminates the fraction. And then because the other fractions are decimals that end, I am okay with making those decimals. And then you still have to multiply it by 7. So now you follow the rest of the steps you normally would. Check if you need to distribute, which you don't. Check if you need to combine like terms on each side, which you don't. Like there's no like terms here, there's no like terms there. So now it's just moving the variable to one side. It's up to you which one you move. Do you want to move the x or the 3.5x? The 3.5x? And how would you make it cancel over here? And then whatever you do on one side of the symbol, you do to the other. Now, we'll go with this. Personally, I would recommend moving the smaller one because then it's less likely you'll have to work with negative. But regardless, as long as you still follow all the rules, you will still get the same answer. So that's going to be a 1 minus a 3.5, which is a negative 2.5, is what the x becomes. And then bring down everything else. So minus 1.4. You don't flip the sign when we subtract, and then 21. So does this make sense so far? Okay, so yeah, there was a 1 here, so you got to do the 1 minus 3.5. That's how we get this. Now it's just about isolating the variable. So start with what's farther. Would that be the negative 2.5 or the 1.4? The 1.4 is farther. So the 2.5 is like right up against the x. So this is technically farther because it has that symbol in between. So how do I make a negative 1.4 cancel? So we're going to add 1.4 to both sides. On the left, I just have the negative 2.5x. On the right, 21 plus 1.4 is 22.4. And now what's opposite of multiplying a negative 2.5? So we're going to divide that. And whatever you do on one side, do to the other. Now, do I need to flip the inequality symbol when I do that? When I divide a negative on both sides? Anyone? Do I need to flip the inequality symbol when I do this? Yes, because it's negative. So don't forget to do that. So that makes this, instead of less than or equal to, positive or not positive, greater than or equal to. And then I still need to simplify this. So then it's 22.4 divided by 2.5. And that's 8.96, and it's a negative 8.96. And now we got the right math algebra. So yeah, remember, flip the inequality symbol anytime you multiply a negative on both sides of the symbol or divide a negative on both sides. Anytime you do anything on both sides, just check to see if it's one of those two things that flip it. But yeah, if you move the smaller variable, you usually won't have to worry about that. Because you won't have a negative if you do that. So that's my answer. And notice it's not one of my multiple choice, because what this one's saying is which value of X, so what can I put here to make the inequality true? So I want to pick an X value that will be greater or equal to negative 8.96. So which of these numbers is greater than negative 8.96? I know negatives are like a bit more difficult. Like, think of it, you owing someone money. Would you rather owe someone $8.96 or like $11? The $8.96. Would you rather owe them $10 or $8.96? Would you rather owe them $9 or $8.96? And then would you rather owe them $8 or $8.96? So then that's why I should use that one. All right, I know that one's the hard one. So at least we did it right this hour. So questions on this one? Questions on others from any of them? Then from the constructive response, not all of you have that finished earlier or showed it to me again. Okay, so number 3 on the constructive response, if you guys didn't get that one. So word problem, let's read it. Usually you have to go back and read it a few times to get the parts you need, but first you should read it just to see what's going on. So suppose you buy flour and cornmeal in bulk to make flour tortillas and corn tortillas. Flour costs $1.50 per pound, cornmeal costs $2.50 per pound. You want to spend less than $25 on flour and cornmeal, but you need at least 6 pounds altogether. And part A says, create a system of equations or inequalities that models the situation. So that's up to you to determine which you need. I mean, to kind of give you a hint, this whole part 2 has been about inequalities, so hopefully you know to make inequalities. But you can tell based on the signal words around our totals. So always start by like picking out the totals. Table 2, can you tell me one of the totals on this one? 25. So they want to spend less than $25 on it. So what they're spending, we'll write over here with like math symbols and stuff. But if I want to spend less than 25, should I use this symbol? And then if I want to spend less than 25, am I allowed to spend exactly 25? All right, no, otherwise it would have said 25 or less or something like that. So use that symbol. And then we'll come up with what goes on that side later. Table 3, can you tell me the other total that's in this? And it says we want at least 6 pounds altogether. So should I use this symbol? So then flip it around. So if I want at least 6, I'm allowed to have more than 6. Can I have exactly 6? Then put the line underneath that one. Then you also have to define your variables, so kind of see what's going on in the situation that can vary or that we're trying to figure out. Label that with variables. And then since our first total was for like money, probably keep your dollar amounts with your dollar amount total. So what should we write on the left side of this? So what's contributing to the $25 that I have to spend less of? 150 and 250. Now, it's not gonna be like 1.5 plus 2.5, like there needs to be other stuff there, so what other stuff do I need? If it's 150 per pound of flour, how can I represent that in like math? So we can make flour X. So 1.5x, and we can make the cornmeal Y, which is 250 per pound of that. And then what needs to go in between them? Plus. Because combined, like you need to spend less than $25. So combined means add. So this is our first inequality. Our second inequality, what's going to go on the other side of the 6? X plus Y. And then you also need to make sure you define your variables. So even though it might seem really clear to you, make sure you put X equals, what did X represent? Good. Pounds of flour. And Y was the pound of what? Corn. So that is 5 points on the test just right there, making sure you tell me what your variables mean and be specific. Don't just tell me X is flour, Y is cornmeal, because then, like, what about it? Is that supposed to be the price of it? Like, I shouldn't have to guess, otherwise we'll lose points on that. So that covers the making it. Questions on that, or? Okay. So then this part is about shading it. So I will say that one of the graphs should have had a dashed line, and that's the oversight on my part. But they already graphed the lines for you. You have to include the shading. So it's up to you how you determine that, whether you like look at them each individually, make them both slope-intercept form, and compare the shading for that. If you're doing it by hand, it needs to be in slope-intercept form before you do that. So let me rewrite these. Okay. So let's start with this one that is more easy to put in slope-intercept form. How do I get the Y alone on this one? Table 1, can you tell me? How do I isolate the Y in this one? So we're being into it. How do I make that X go away? Subtract it. And whatever you go on one side of the symbol. And that one step alone gets it in slope-intercept form, because now the Y is isolated. I don't need to flip the sign when I subtract. So this is the one that has a Y-intercept of 6. So if you look at which line that is, 1, 2, 3, 4, 5, 6, that's this line. Based on the way the symbol is facing, Y greater than or equal to, how should we shade it? Above or below? Above. Now, if you're shading with your pencil, make sure you shade lightly at first. So we still need to see where the other one is supposed to be shaded at before we like identify what our solution is. So the solution is where the shading overlaps. Just lightly shade, we're not done yet, we still have to shade the other one. Now the other one takes a bit more steps, really just 2 steps. How do I cancel that 1.5x? Subtract it. And then you get 2.5y less than, and these are not like terms, so don't try to combine them, just rewrite them. And then opposite of multiplying 2.5 is to divide it. Now whatever you do on one side, you do the other. And truly, you don't need to like fully simplify it. The reason we did that is to see if we needed to flip the sign at all. And did we need to flip the inequality sign? No. So it's y less than. When it's y less than, where do we shade, above or below? And it's this line, because we already determined the other line was that one. So underneath this one, you need to shade below that. And it needs to be really clear to me what the solution to the system is. So mine has like different colors. Yours, you can shade like darker where the solution is. So where exactly is the solution for mine? What color? The green. So then if this were me, I'll make sure like I put a big S there, or make that part really dark and the other part's lighter. But it needs to be really clear what the solution, not both constraints is. So that's what we said. Both. So questions on that? Okay. So test tomorrow. Yeah. You can also upload it to